Welcome again, Wildcats. All right, so today we're looking at Monday, March 27th, and we'll be looking at logarithmic rules on page 67. And to save some internet space and one less video for you to watch, I'm just going to let you know that on Tuesday, March 28th, you have a take-home quiz 10, okay, which is due on Wednesday. So you can take it home, but if it's not returned on Wednesday, then you get a 0. And it stays a 0. There is no getting another day. So you get it on Tuesday, you take it home, it's returned on Wednesday, or it's a 0 and it stays a 0. Okay, so keep that in mind. All right, so with that, let's get back to Monday on page 67. All right, so page 67. All right, now if you're looking at this and like, wait a second, I don't have this page, it's in Schoology, so you can get it from Schoology and print it out. Or you can just, if you're bored, you can write it all out by hand. We can do that too. All right. So what we're looking at is logarithmic properties. Okay. So what we want to look at is going from the exponential equation to the logarithmic equation. Okay. So at this point, you want at least two colors. I'm going to have yellow, blue, and blue, blue. But what we're looking at is B is in yellow. Okay. So B is here. B is also here, so it's going to be yellow and both. So the B here is the same B that's in here. Okay. All right, and then we're looking at the A. The A. So the A here is the A that corresponds to the A here. Okay. And the X here corresponds to the X here. Okay. All right, so with that, let's move on to some more of the properties. All right, so when you have log B of x times x, now that's condensed. To expand it, it is log B of x plus log B of y. Okay, so you could say that the log of a product is equal to the sum of the logs of the arguments. Okay. All right, so pause a minute to write that down. All right, next one. Log B of x divided by y. Now that's condensed. To expand it is log B of x minus log B of y. So you could say that the log of a quotient is equal to the difference of the logs of the arguments. All right, so pause a minute to write that down. All right, next one. We have log B of x to the p power, which, let me say, make sure I say this right. So this becomes p times log B of x. Okay, so the log of a number raised to a power is the same as the power times the log of the argument. Okay, another way to understand this is that the power becomes the coefficient. Okay, the power becomes the coefficient. All right, next, log B of B to the p power. And before, actually, let me roll back a little bit. These are the inverse properties. Okay, so we can really kind of start here. Log b of b is equal to 1. Okay, so we know if that's 1, and we know by the raised to the power rule, this becomes p, but that's 1, so p times 1, which equals p. Okay, so looking at kind of an example with that. Okay, so log of 2 to the 6th power, 6 goes to the front, so that's 6. But we know log base 2 of 2 is 1, so 6 times 1 equals 6, so x equals 6. So we can say if the log base and the argument are the same, so here's your log base, here's the argument. Whoa, time was frozen. So this is the base, this is the argument. Okay. All right. So here we know the base, and it says here if the log base and the argument are the same, it is always equal to the understood power of 1. So this is equal to 1. Okay. All right. And the next one is the change of base properties. So when you have log of b of n, this is log of n divided by log of b. Okay. So this is using an example. So this becomes log of 32 divided by log of 4, which we'll just leave it like that, but in class, remind me and I'll show you how to put that in the calculator to get the number. Okay. All right. So again, using the change of base property. So log base 2 of the argument x plus 1 becomes log of x plus 1 divided by log of 2. And I've kind of ran out of, or log of 2. Kind of ran a space, but that should be equal to f of x. I managed to break both pencils. So give me a pause a minute and let me get some new pencils or sharpen these. I apologize. Write that down. I think this is the first time in a video that I've run out of pencils, but when you run out of pencils, this is the way to go. USA Gold. They're premium American cedar pencils. So when without pencil, go with the USA Gold. They're the best pencil in the world. All right. And like I always say, math American, write American. All right. So here, and so that's equal f of x equals, so I kind of ran out of space there. All right, so I'm assuming since while I was getting pencils, you finished up the notes, so let's look at the examples. All right, examples also again on page 67. All right, so I'm really just going to look at the first example in each row, and then we'll go over the other examples in class, okay? But I just want to give you just a sense of each row to kind of get you started, okay? All right, so rewrite the equation in exponential form. So you're basically going to want to have this page kind of next to it each time, okay? So here we're given the logarithmic equation and we want to go to the exponential equation, okay? So we know that log base 2, the base 2 in argument 8 equals 3, okay? So I might, just above this row, just to kind of remind myself, but I have log b of a equals x, and that is the log, okay? And then the exponential is b of x equals a. So they want to go to here, they want it in exponential. So I recognize my base. My base is 2, so my 2 is here. Okay. The x position, okay, which is the 3, equals the a value, which in this case is 8. All right, and that's now in exponential form. All right, now rewrite each equation in logarithmic form. Okay, so now we're going to the logarithmic form. So we're still going here. So we know that the base is 2, so that's log of 2. Now we're looking for the a value, which is here, so of 8, which equals the x, which is in this position, so that's the 3. So you're just referring to these and understanding where the b is, b's here, and then converting forms. Okay? All right. Now it says evaluate. Okay? Well, to evaluate, we can actually go from log to exponential form. Okay? Actually, no. You know what? Let me talk about the evaluating in class. Okay? So let me explain how to evaluate in class. All right. Expand each logarithm. Okay? So here, I first see that I'm looking at the product. So I'm doing product. So I know that this is condensed. I'm going to expand it. Okay. So I'm basically looking at here. I see this. So I'm in the product. Okay. So I know that I can write this as the log of x plus the log of y plus the log of z squared. Okay. Now the end one, that looks like the raised to the power. Okay. So I know that the power becomes the coefficient. So this becomes log of x plus log of y plus 2 log of z. So I've expanded it as far as it can be expanded. All right, so pause a minute to finish that up. All right, now it says condense each expression to a single logarithm. Express as a single logarithm, simplify if possible. Whoa. I was thought about that, but I have a feeling that's a lot going on there. So I'll do this entire row in class. I think it'd be better because then if you had questions on that. All right. Use the change of base to evaluate. Okay. I think we can do that. Change of base. Okay, let's see change of base property. All right. So I'm using here change of base property. Okay. So this becomes log of 8 divided by log of 2. And then I'll explain how to put that in the calculator when you get to class, okay? Now, here's something to be a little concerned with, and you have to figure out how to resolve this. This is an advanced academics class. Now, you won't be given, in a regular Algebra 2 class, I would basically give this sheet to all the students during a test. But because it's an advanced Algebra 2 class, you have to memorize all these formulas. So you might want to figure out a way to kind of just memorize them and master them for any quiz or a test, okay? So keep that in mind, okay? Now, I will say that the quiz on Tuesday, I'm not going to put anything on here on the quiz, so you can get time, but just knowing the coming up tests, you're going to have to find a way to memorize all of these properties, okay? So keep that in mind. All right, but with that, that kind of sets you up for class on Monday. And with that, have a logarithmic, exponentially, wildcatly awesome day.